Ever wondered what the strongest known acid is? You might think of hydrochloric or sulfuric acid. Those are quite acidic because sulfur and chlorine are strongly electronegative, which means that they try to grab the hydrogen's electron, turning it into a proton. This is usually where people stop watching the video, but we're almost at the most interesting part. You've probably heard of the pH scale, but for acids as strong as those that we're going to see, it won't be enough. So we use the Hamett acidity function, which is defined based on the dissociation constant and on the logarithm of the concentration of the acidic form and the basic form. It doesn't involve water in its dissociation constant, unlike the pH scale. An interesting acid is the Piranha solution made of hydrogen peroxide and sulfuric acid. It's called like that because it can dissolve anything organic and turn it into carbon dioxide. It's used to produce computer microchips. Next is triflic acid with a Hamett acidity function of -15. It's useful in chemistry as a catalyst, but it's extremely corrosive. Inhalation will cause tissue degradation after some time. We also have magic acid, and no, it's not a joke, that's actually its real name, which is strong enough to dissolve paraffin, which is like the most inert substance you can find. There are many other superacids, the strongest of which is fluoroantimonic acid. But let's examine one particular case, carboranes. All the acids we described before were extremely corrosive and would probably melt off your lungs if you breathed them in, but this one is extremely strange. Somehow it only protonates weak bases, even though we can't even find an upper bound for its acidity. And it's described as a gentle acid, which doesn't mean that it isn't corrosive, it's just extremely selective and behaves in a strange way. But why is carborane so acidic? Well, the answer is that it's a really good base because the electron is completely delocalized, meaning it very easily accepts an extra electron since it will be spread between all its atoms. This means that the hydrogen atom can easily give an electron to become a proton, and in some cases it's even resonance stabilized.